Another way that I would get familiar with the part is to go into Analyze and choose Direction Analysis, and I box pick the part, middle click. Yeah, by the way, the middle click is always how you get from step 1 to step 2. And I have to set the direction of this arrow. Whenever you see this arrow, and normally there's two of them, there's one here and there's one there. It's the same arrow, just in different places. The tip will always flip it, and the base will always define vector. So I'm going to change it to cylindrical conic center, pick this boss, and now the arrow is facing up like this. And so I'm interrogating the draft angles according to this direction, which happens to be the die tip. So when I set the mouse here, in fact, let me show this color dialog. You can see that the vertical areas are purple, the horizontal areas are green. Wherever the mouse sits on the model, I get a dynamic value. And so right away we see we've got some work to do in order to put some draft on these ribs, and we'll do a couple of them for sake of training. And I can flip the arrow and look at it from the other side. Right away I see there's a problem here that we'll probably see more when we go into quick split, but the part designer put the draft on this window in the wrong direction. So we do have an undercut here, and then this window of course is vertical, so it could go on either side. Okay, in the same way that we have the direction analysis, which is for looking at draft angles, we have curvature map. We box pick the part again, middle click, and now what we're looking at are radius values. In fact, right now we're set to the out. Oh no, it is the inside. Okay, so wherever my mouse sits, I get a value of that radius. And this is good for determining what areas can be machined versus what areas might require EDM. And if I click on flip, it then goes to the outside radius, and again you just let the mouse sit there. I'm not clicking, I'm just hovering, and it gives me values based on where the mouse is sitting. Yeah, so here we can see that probably a half-inch ball would be capable of finishing this 3D surface. Okay. Now there's not much more that I would do with this file because this is our master file. We don't want to start splitting surfaces and creating runoff or doing any kind of work in this file. This file needs to stay our master file in case we get an engineering change from the customer. We want to be able to compare something against it. Plus we call it our cover our ass file, right? This is the data the customer gave us. But I would do one thing in this file, and that's create a coordinate system that'll be a little more useful at the next step. So up here under datum and then UCS, this one is my favorite, center of geometry. You can just about use this all the time. Well, first let me show you. If I box pick the part, it gives me a bounding box of everything that I picked. Again, here's my arrow. I can set this to cylindrical conic center again. This arrow kind of represents the Z positive direction. And this looks okay, but all this ribs and stuff is going to be in the core side, so I'd prefer to flip that. Again, the tip of the arrow flips direction. This is a little bit hard to see, but there's the preview of the coordinate system that I'm about to create. So there it's running in X and Y and Z. This point that it defaults to happens to be dead center on the bounding box. I could choose the high point or the low point if I wanted to, but this is okay for now. I'll go ahead and accept that. And then we need to activate it. This UCS is red, which means it's active. The one that we just created is blue. There's a couple different ways that we can go about activating this one. The easiest of which would be to left click on it and then right click and choose activate. I can also rename it here, but it's a good habit to get used to using this UCS manager up here. This one's very important. The way that it works is when you first go into it, it's set to select UCS, and that means that I come over here and I pick on them and they show up in this window. But you can also choose all UCSs in the active file, and that's going to put as many coordinate systems here in the list as exist in this file. So here there's only 2, and we're going to rename the one that we just made. And we'll call it die tip. Again, it's a great habit to rename these coordinate systems because sometimes when you're working in assembly files you tend to get a few of them, so renaming them will help you keep track of them. And okay, now it's green. It's kind of selected right now. No, it also wasn't active. Hold on. Activate. Okay, so red means it's active, and all of my views now will be updated to the active coordinate system, so I can create any coordinate system that I want on this part, and the views will all update according to the active coordinate system. So that's all we're going to do in this file. Let me just show one more quick little thing. When I created this UCS and I picked everything, I had the option of only picking maybe one surface. So let me show you. If I choose datum, UCS, center of geometry, I could pick this one surface if I want, and it's going to want to give me a little bounding box of just that one surface, and I'm in the center of that bounding data, so that's as good as being on the center of that round face. And if I pick, you'll get the idea, I pick this surface, now it's a bounding box of those two faces. So you can get pretty creative in how you create your coordinate systems with this center of geometry tool. It works really nice. Okay, so again, that's as far as I would take this file. I would save this as my master file, and then we're going to use one of the wizards to carry it further.